Hi everyone, so in today's lesson we were going to see how we can use the periodic table to find information on elements, and we will be seeing how to use this to find the formula of different compounds, because when we have been talking about carbon dioxide, you've seen CO2 somewhere. When we were talking about water, you've seen H2O somewhere. So these are chemical formula. So we're going to see how we can get these chemical formula, what they are, how we find them. Okay, so the periodic table, this is a copy of a periodic table, and the periodic table has a lot of information. It has the names and symbols of elements. In here we don't have the names. This is another periodic table. It's the same thing, it's just that here you have the names. You have other additional information like proton number, atomic mass, that you're not going to use at this level, so please ignore all the numbers that are given over here. So you're just going to be using this periodic table to find the names of the elements. So in the periodic table, you can also know if the elements are metals or non-metals. Like you can see here, all the elements that are in dark here, all these are metals. So you have many metals, more metals in the periodic table. All these are metals, and all the light ones, these are non-metals. So there is a zigzag line over here, that staircase line or zigzag line that separates metals from non-metals. So the dark ones are metals, all the pale ones are non-metals. Actually over here on the borderline of this, here, boron, silicon, arsenic, tellurium, and astatine, these elements are actually, they share the properties of metals and non-metals. These are actually called metalloids. They have both metal and non-metal properties, but for now we're just going to consider as overall, so metals and non-metals. And valency of elements that we can find from the periodic table, valency is actually the combining power. So it's the combining power of the element. And what does that mean? So you can have elements, so here I'm representing the elements as a circle. So if an element has valency 1, means that valency are numbers actually, so you can have valency 1, 2, 3, or 4. Up to your level, you'll have just up to 4. So valency means how many other atoms it can combine with. So if it has valency 1, means that it can combine with other 1 atom. If it has valency 2, it will combine with 2 other atoms. If it has valency 3, it will combine with 3 other atoms. If it has valency 4, it will combine with 4 other atoms. So this is what is meant by valency. It's a combining power of the element. And where do we get the valency? The valency can be obtained from these numbers over here, indirectly. So what are these numbers? Actually, all these numbers, they show the group number. These are the group number. And the group number, it should actually be written in Roman numerals. So it should be written actually in Roman numerals. So we're just going to cut this off. Right. Now, what that means, it means that all these elements over here are in group 1. Everything over here are in group 2. Right here, we have the elements in group 3. Here we have the elements in group 4. Then we have the elements in group 6. Here, group 6. Then we have group 7 over here. Sorry, 7 was wrongly written, so group 7 is good now. And then group 8 or group 0, So that's the last group. So you see there's 8 groups of elements. So we have all these groups, and these are the columns. So group numbers, they're actually the columns in which the elements are found. Everything that is over here, we're just going to ignore them for now. These are called the transition elements. We're just going to ignore them for now. So let's just not consider that. We're just going to be looking at group 1 to group 8, all of this. Now, in this task, what you're going to do, you're going to find the element and its corresponding symbol. So you have this periodic table over here. So you're going to find the element and its corresponding symbol. These you should know them. You should know these elements and their corresponding symbol. When you're writing the symbol, just be careful. The first letter of the symbol, first letter, should always be capital. And if you have a second letter, some of them have 2 letters, some of them have just 1 letter. The second letter should be small letter if you have one. Right? Let's see, for example, in the periodic table, let's see tungsten. The symbol is W capital. But if you see rhenium, R capital, E small letter. So first letter should always be capital. Let's see another one. Barium, B capital, A small letter. One that has a single letter. Potassium is just K, capital. So be careful. If it has just 1 letter, it should be capital. If it has 2 letters, the second letter should be small letter. So these are all the elements for which you should know their symbols. So you're going to complete them. And you're going to classify these elements as being metals or non-metals. So have a look at the periodic table, this one, and you're going to see if the element is in the black box, so it's a metal. If it is in the gray box, then it's a non-metal. We're not going to look at metalloids for now. Okay.